that really were independent, you could get some pretty impressive benchmarking.
Yeah.
I mean, there's a lot of use case specific
I think
weirdness.
as an overall, that you tend to use all CPUs instead of generate better strategy.
Probably. I don't know yet.
The capacity thing I was referring to, that is,
No,
maybe I don't understand, but I just want to check it's my understanding. If you had, say I had two clusters with two sets of CPUs that were identical, all the CPUs are identical, right? But I've got say 4 threads. So I've got 4 CPUs, I've got 4 threads. But some of them are really long running but low priority, and the other ones are really short running but high priority. You're going to get into a situation where, actually maybe that's the right number of threads. Say I have 1 thread and 4 low priority threads, 1 high priority thread, 4 low priority threads, right? So my high priority thread is and 2 CPUs. Am I going to get in a situation where I'm only running 1 high priority thread on 1 CPU and all other low priority threads on the other CPU, even though their average runtimes might not benefit from that in any way, shape or form?
Yeah.
That's what I meant by the capacity problem. It's nice, it's kind of incompatible with that. So you have a situation where, so we don't have PJT's load tracking patches. If we have PJT's load tracking patches, the logic would say, well, you know what, I'll put 2 of those low priority threads along with that high priority one, because the high priority one only really runs for 1 millisecond at a time, and I'll put the other 2 on my other core, and that's probably going to be, from a capacity point of view, the most balanced way of doing it. But the way the priority is defined is just giving me a completely inefficient schedule.
Again, it's a
In a point, and if you look at the pure runtime point of view, you should have the fair, the most the
fair scheduling.
yes. We just need to keep in mind
And
that
we shouldn't care
it's
about
amount
the
of
number actually.
fair scheduling.
I guess in a way you can kind of see how Linux is really being designed for big iron.
Yeah.
The assumption really is that your threads tend to run
No, yeah,
for a long time.
clearly,
And that's why,
for long running,
nice,
for long running thread, when you have a large number of running thread, when you have some what we can call always running thread because it's running so long that you have a stable situation in the scheduler, it's quite good. Now in our situation, we have not so long running task. Web browsing is half a second.
almost anything.
And you have 1 or 2 threads that will run half a second. The other one will just wake up. I can show you maybe. It was.
In mobile, I bet almost anything in desktop is pretty similar. Generally, bursting is probably the more common behavior.
Yeah, I thought the scheduler tried to figure that out in the past.
But I think the fundamental is right.
But for the load balancing, my understanding is that it doesn't. The CPU uses that.
Right-click that bar and send it to the workspace that's being...
Is what tells you how
Yeah.
long it's going to run.
I don't quite know how that's calculated, but
Is
No, I
it true
see.
that I use
8 GB.
Because I'm in the same workspace.
balance?
Oh, you
and
are in the
balance
same
and
workspace.
This is the same workspace
class
on
one
the
is
side.
what we were talking about. Load
And
weight
it's just that
itself is unbalanced and
Well,
balance.
his
I
load,
don't
I
know.
guess,
You, this is the...
if you set your important thread to really
I still-
low
your slides.
night, or you set the unimportant thread to really
दोनों
nice values, when this
Okay,
scheduler
that's-
is doing the right thing.
दोनों का है ना ये बचा है ना
So,
the camera charge भी बंद होने वाला
say 2 CPUs.
Yeah.
Right, one of which is
Ah,
Okay.
really high
it just
priority.
if you have the size.
Size matters.
The capacity is the nice value, effectively. One CPU is the one thing.
best fit
So
Sorry,
maybe that's what you want.
Yeah, F5.
By the definition of nice, that's what I'm saying.
Yeah.
The problem is that in mobile.
So this is a page rendering. So I agree that you have only 1 long running task. What about the
Don't need another CPU time, which is
yeah? What about the fairness when you have some small running task?
what happens
Yeah.
in
So, I mean,
So I agree that in this case the scheduler and
That's the
the nice priority is not so easy to interpret.
that's a problem.
yeah. So would it be better to use RT for that guy that has to wake up quickly and run for a short amount of time?
LT?
Yeah.
Yeah, that would be fantastic.
Yeah, but
I mean,
Does Google do that with some threads?
I think maybe deadline scheduler could be better.
deadline's better.
because you give an amount of bandwidth.
RT is fine as well. I mean, it can still get divided if you have more than one,
Yeah.
but
But in this case, you must, when you set a RT priority, you can't just take care of your own thread. You must take care of all the
Yeah,
threads
that's-
and all the system for all the
The
applications.
other
Well,
problem is-
all the RT threads.
Yeah, no, I mean, if you want to remove the CFS by RT,
Yeah.
when you choose for priority, you must take care
Well, we
of...
don't want to remove
No,
it, but we
it's
want to
like-
get real
No, yeah.
priority, right?
Yeah.
As opposed to runtime
Yeah,
fairness.
we can run them together, no?
yeah.
And just have that whatever special low learning as a RT priority and rest.
Yeah.
Rest
Yeah,
as
maybe, we can do that.
Okay.
But
I don't know.
normally RT is for short
Yeah.
tasks because
I
you're just
Yeah. I say that, but
You
I
take
know
a
it's a bad
CPU.
idea.
you take the CPU for you for here is I think it's half a second, so for sure nobody will have access to the CPU for
And I
half
know
a
that
second.
the guy that I'm going to put this RT isn't as well behaved as he needs
Yeah.
to be to really use
You
RT.
must take care, of using RT. You can be in a situation where you will not have the CPU
Right.
for a while.
I
But
can't
tell
guarantee.
me something.
Yeah.
You,
Yeah.
you could do that. I mean, it can have bad effect also.
Yeah.
If you really want to do that,
Yeah,
let's say in an embedded system where I really have some kind of a emergency medical sensor for which there is some app which I really want to have always the
yeah.
priority. So I can call that as a RT and rest of my host.
Yeah. Both can work together. Yeah.
Again, and this was this Sked 5 all the way through. So you can do a full stack with Sked 5.
Yeah.
But
Probably.
you definitely get into some of the problems.
Yeah,
you have
sure.
to be careful. But you can do a full.
Yes, I agree. You can do a full things, but you must in fact.
The weeds.
Yeah, you must have a complete system point of view in this case. When you are selecting a priority, you must take care of everybody. And in our case, it's impossible.
Yeah.
But deadline in this case is expected to give us better determinism, right?
Yes, because you can cap the running time of a task. So,
Okay.
What's the status on UAs? I mean, what's the last status on UAs, Max?
I think you reposted an update the other day.
yeah, and it just wait. I think that everybody is waiting for the use case that will say, okay, we must. Everybody say, okay, it's a good scheduler, will take benefit, but there is no real demonstration of that.
I wonder if we have that kind of use case.
Yeah, that's what I was thinking. Some kind of some of the stuff you highlight. A good example.
Audio. Who was looking for an audio playback use case?
Yeah, so we did try pulse audio. I did.
Yeah.
You did your own experiments. I did some pulse audio as RT.
One main,
Even to do a G streamer thing,
maybe.
be simpler, fewer dependencies.
Audio could benefit from an EDF kind of thing, but I sort of wonder if semantically all you really want is just a way to say not only maybe do I want my niceness to increase, but I want to run now. Like you don't have to necessarily use RT or EDF for that. You would just need maybe some new flag or something that just says, it's not rerun time or something that I'm interested in. It's
so
actually like scheduling.
In this case, you have
First.
some others. But first, against which other task?
No, I'm asking you.
No, in fact, the goal is that. I agree that we can say, I want to be.
Right.
I want to run first before other, but who are the other?
Yeah,
the scheduler can't know.
But, obviously, for some cases, we actually don't care about being fair, right? I mean, we want to.
Yeah, we don't care about being fair.
No, but I mean,
In
what
this
is contradictory
case.
with the design goal, CFS is what
Definitely.
Yeah.
CFS
Oh,
is
you were
not
talking
fair.
about being first inside CFS.
Yeah.
Yeah,
But in
and
this-
maybe maybe that's
Yeah.
wacky, but it almost sounded like that's what you wanted, right?
But my understanding was, I don't have the least experience here, but my understanding was that some of these threads in Android around audio and even Surface Film, I think it was audio, had very high priority.
Yeah.
And that's really just a guarantee that they will run.
Yeah.
So isn't that